Hi guys, this video follows on from the PS2 to Amiga Mouse Translator hardware video, and the first thing I did was toggle some LEDs. With working LEDs on the interface board for feedback, I can take the Amiga out of the picture and use a power supply as a test jig, and using this power supply to run the thing and save the Amiga turning off and on again. And here's the changes to the original code for the effect I just showed you. Basically a couple of software flip-flops. The routines just toggle the state of a pair of bits for left and right button pushes, and that's the state of the bits are represented by LEDs. Not incredibly practical in my first implementation. The button routines get called every time you move a mouse and the button's held down, as you can see here, so the toggling happens a lot. And just another experiment here with momentary buttons. And yay, my mice have arrived from eBay. These are the 3 optical mice that are identical. 2 buttons, they're all optical. Scroll wheel and a middle button, which pushing the scroll wheel activates. And though it looks like the 16F84A is still in production by Microchip, from here on I've moved the code to the 16F628A. It's not going to offer anything much more, just that it's probably more readily available. And one big ugly contraption with a lot of wasted space. Quite shameful considering people are making these with surface mounted devices and fitting them in the D back shell, but I probably am going to expand on this and add relays to it to control something else, so it's not that bad. And this illustrates changes to the author's original schematic, so notice there's no LEDs connected to port AO or port B7. Back on the author's project page, you'll see his original diagram, and the source code is right there for everyone to see, right there on the page. And that does compile for the target processor, and I'll just release my changes on Aminet is the first place I'll try, and that keeps in line with the license agreement. Original copyright 2001, so here I am almost 6 months shy of 15 years later making changes to it. There wouldn't be a lot of source code with that sort of lifespan. And the first change to accommodate the 16F628A there is moving the general purpose RAM to a valid area for that chip, which is what's being shown here. And the first change to make, because this chip has analog ports, is to set them digital, so that's happening first up. And the indented line there is clearing the bit for Tris A bit 0 to make it an output, so that's one of the LED outputs. The other LED output is port B7, and Tris B is already set. And these are the labels that are called whenever a right or left mouse button is being pressed or held down for any movement. This is where the signals are sent through to the Amiga mouse buttons, and then the following 3 lines in C or BASIC would look like something like if the middle mouse button is held down, then send the signal through to the LED. Bit test F, packet 1, bit 2, where packet 1 is packet 1 from the PS2 mouse, and bit 2 is where the middle mouse button will set the bit. Now, if you had in mind to use these pins to control buttons of a GoTech, just keep in mind that the pins might not be 5 volt tolerant, so you might need a resistor divider to get down to 3.3 volts. It does look like these button pins are normally held high with internal pull-up resistors and then sent low with the buttons. It's nice to see I haven't broken anything. Mouse still works. And for the left mouse button, it'll still get sent through to the Amiga. But if I hold down the middle mouse button, the left and right won't get sent through to the Amiga. It'll only activate the output from the mouse translator. And that should be enough to cover controlling a GoTech or something else, and I'll see what I can come up with for expansion in another video. That's all for now.